So, hello everyone, and welcome to today's academic webinar on teaching multivariate methods, with a focus on teaching two methods in particular: factor analysis and structural equation modeling. This webinar will be delivered by our US academic ambassador, Ross Methusalem, and I'm also pleased to introduce myself. My name is Paolo Chiappa. I'm the academic program manager of JMP for EMEA, and I'm really pleased to be your host today. If you have any questions today, please use the Q&A icon you can find in your Zoom interface. If you have more general comments, the advice is to use the chat icon. But again, to ask specific questions related to what you will see today, we really recommend the Q&A button, and we will do our best to answer all your questions. One last thing. In order to help you better, we would like to understand also what statistical software you have the most experience with to teach these and other statistical methods. So if you haven't done so yet, we kindly ask you to respond to the little poll that you should have seen when you have joined this webinar. This will provide us with a rough estimate of the approach we have been using so far, since of course every software offers kind of a different style to teach and learn statistical concepts. And the interesting thing is that if you already have like data sets you are using classroom, and maybe these data sets were created also with other statistical software, it is very likely that you will be able to easily import them into JMP and then take advantage of its particular interactive and visual approach. Okay, Ross, you're up.
All right, thank you, Paolo. Let me pull my screen up and we'll get started. So everybody, thank you for joining this academic webinar where we're going to cover using JMP tools for teaching factor analysis and structural equation modeling, or SEM. And these are multivariate methods that are particularly common in the social and behavioral sciences, business, marketing, economics, and healthcare, just to name a few. So pretty broadly applicable techniques that we're going to be talking about. Now, today I want to mention that if you're new to our teaching webinars, they generally provide reviews of relevant JMP tools, tips for using those tools with students in a classroom setting, and also teaching resources, example data sets, and so forth that you can actually incorporate into your course if you like. Today's topics actually are more statistically sophisticated than some of the other topics we cover, especially SEM. I'm sure many or all of us recognize or resonate with that. And so we typically stay high level when it comes to the statistics themselves, because if you're teaching this topic, you probably already have some background in the area. So we'll try to stay kind of high level with the statistics and really focus on the tools and tips for using them with your students. So today, we're going to cover factor analysis and SEM, like I mentioned. If you're looking at my JMP journal right here, you'll notice actually that I intend to begin with exploring multivariate data. And that's because I think most, maybe even all of us would agree that when teaching any kind of data analysis, multivariate methods included, it's important to teach students the right ways to first just investigate and explore their data before launching into sophisticated analyses. And so that's where I'd like to start just briefly, only for a few moments here. A couple tools I want to introduce you to for exploring multivariate data before moving on to factor analysis, and then covering JMP's structural equation modeling platform in general, just to give you an idea of how it works. And then we'll see two specific examples of that platform in action. One will be confirmatory factor analysis, where we're also going to see a multigroup measurement invariance example. And then we'll finish up with a structural regression example. So let's get started with exploring multivariate data. And first, I'm going to pull up the data table that we're going to use. This is the body measurements data table. It is bundled with JMP. So if you go to the help menu and the sample index, you can find it there. And I like this data set when demonstrating tools and techniques for multivariate analysis, because it's relatively simple, 22 rows, 11 columns, and it's relatively intuitive in that these are just measurements of 22 individuals' body mass, or say forearm and bicep circumference, or their height. So this is a data set that anyone can immediately understand and maybe even develop some expectations or intuitions about the types of relationships or correlations we would see between variables. For example, we would expect maybe forearm and bicep circumference to be highly correlated, whereas maybe forearm circumference and height would be less highly correlated. So I'm about to show you the multivariate platform in JMP, and this is just an example output. I'll show you how to make this in just a second. This is a great tool for multivariate data exploration. You can see we have actually a pretty rich graph in front of us here that combines a scatter plot matrix with a correlation heat map. So we immediately can assess all of the pairwise correlations and the shape of relationships between our 11 variables here. So one thing we might notice, for example, up in the top, we have a correlation of 0.9 between body mass and forearm size, and that's also captured by the scatter plot and density ellipse right here. Or we might notice over here in the final column, these are all the correlations with the head circumference variable, and they all seem to be pretty low relative to the others, except maybe height actually isn't highly correlated with many of these as well. Below that, we have all of the pairwise correlations. So the full statistical report underlying that visualization that we just saw. And then JMP always having interactive graphics. I've included just a quick example here. Down at the very bottom of this report, we have a multivariate outlier analysis. So these are in particular jackknife distances, but if you're not familiar with that, just know these are essentially measures of how far away each point is from the multivariate mean. And so if you get up above this upper control limit here, we have evidence that maybe you're a multivariate outlier. What we can do is select that one point that's sitting right on that threshold there, and then actually see where that point lies in our scatter plot matrix above. So in this particular example, that individual is high on height, which is the y-axis here in all of these scatter plots. And what's driving it to potentially be an outlier, maybe it's that, well, for the height, for example, we have a relatively low forearm circumference here. Same actually seems to go, if we move just to the left, for the body mass. So maybe we have a relatively tall and thin individual. So the multivariate platform is a great way to just visualize and explore correlations between variables before getting into something like factor analysis or SEM. Let me show you how it works. I'm going to go to Analyze, Multivariate Methods, and then just choose Multivariate, living at the very top of this submenu. Grab all of my continuous variables, put them in the Y columns row, and click OK. So this is what a multivariate platform output looks like by default. Up at the top, we have a correlation matrix. So every correlation, including then the values of 1 all along the diagonal here, because every variable is perfectly correlated with itself. And below, we have a scatter plot matrix. So this looks a bit different than the output that I just showed you. First off, it's my personal feeling that a full scatter plot matrix like this, when you're teaching multivariate methods, unless students are pretty advanced, maybe if you're in an advanced graduate course, this might not be intimidating, but I think to many students, just seeing a giant wall of numbers might not be the best way to get them to try to understand what we're really doing and why. So that's why I like to use this scatter plot matrix and customize it instead. So there's a red triangle menu next to the scatter plot matrix, which provides you options for modifying it. And so I added things like the shaded ellipses and showed the correlations and a few others. For all of you out there, I just want to give you a general tip for using JMP. If you want to make multiple red triangle selections at once, instead of going here once and choosing shaded ellipses, then going back and choosing correlations, hold down either Alt on Windows or Option on Mac, and you can just instead make multiple selections at once. So I'm going to turn on the shaded ellipses, the correlations, and that correlation heat map right there. And so now we're back to the version of this output that we started with. Up at the top red triangle is where you're going to find other outputs that this platform can produce. And you're going to notice that there are quite a few. For example, we have the pairwise correlations that we pulled up before. So here's that table right here. And you can sort this table. If I just click on correlation, I can sort it in ascending or descending order. Actually, in doing that, I can see that the strongest correlation of all is waist and body mass at 0.9. And if I wanted, say, those outlier analyses, I can find them right here. Of course, we have things like non-parametric correlations. I could pull up just simple univariate summary statistics if I wanted to. The multivariate platform, I want to stress, is really flexible, highly customizable, and you might have one or more ways you want your students to use this in order to explore multivariate data. So I want to point you to a new feature in JMP 18 that I think is really useful, really in many or most situations, but certainly here. And it's called platform presets. So what you can do is customize your report the way you like it. So here I have a report in the format I want my students to consume. Up in the top right corner, I have this star icon that allows me to save this customized report as a reusable template, or what we're calling a preset. So I can go to save and I could give it a name and save it to my presets folder, which I've actually already done. And so I have this preset called heat map and pointwise that can easily reproduce this output. So if I start over and go to multivariate and I click recall and OK, I'm at the default output. Now, instead of making a bunch of different selections, all I do is go to my presets, heat map and pairwise, and there we go. So in working with really flexible JMP platforms, especially this multivariate platform, I think platform presets, and you can set up multiple of them to have multiple different uses of multivariate data exploration. These presets can really streamline the way that you use this highly flexible tool with your students. Now, once you've set up your preset, just know if you go to, on Windows, go to the JMP menu in Settings. On Mac, you can go to File, Preferences. You're going to find a platform presets section that lists all of the platform presets in your JMP, and you can export them and then provide them to students to import so that they have all of them available. And I think if you're interested in making sure that your students can consume these reports in the format that you want, that's definitely something to consider. So this is the multivariate platform, great for initial data exploration. In just a moment, I should say, in taking up just a minute, I want to make sure that you're aware when thinking about visualizing multivariate data, there's also 3D scatter plot capabilities under the graph menu here. So choose scatter plot 3D, select the variables you want to be able to include and click OK. You'll notice I selected more than 3, and then you get a 3D scatter plot. Now, by default, the points in here are very small. That is so that if you have a very long data table, that is many observations, you can still make out the individual points, but you can right-click, go to Settings, and with marker size, you can actually change the size of those as well. So for smaller data sets, typically want to increase that size. And actually, just to further plug these platform presets, you can see I have one that I've created for Scatterplot 3D called Big Points, which will get us right here. And then under the red triangle, you can do things like add density ellipses. So here's normal, density ellipsoid, or you can even perform basic principal components analysis. And then down below, you can make selections about which variables you want to plot on the 3 axes. So just another great tool for multivariate data exploration here. But that's all I want to say about that. The focus today really is on factor analysis and structural equation modeling. So let's move on to that. Let's talk about exploratory factor analysis first. And to highlight tools and tips for EFA, we're going to use one of the case studies in JMP. Oh, sorry, my browser opened up in another window. Let me bring it on over. There we go. So if you're not familiar, the JMP Academic team creates and curates a number of case studies. We have about 60 now. Each one presents a real-world data analysis problem and walks students through the solution with screenshots and instructions and interpretation of outputs, and provides exercises for students to do as a follow-up. So here we have one, exploratory factor analysis of trust in online sellers. So let me click on the PDF to pull that up. What you're going to find in each one of these case studies is a general background, which you can see in the background section. This just describes the world of online shopping and the fact that there's a proliferation of sellers, and you need to make sure that you're buying from somebody that you can trust. Not all online sellers are trustworthy. And then a specific task. So in this case, we're imagining that Anna, a market researcher, is interested in underlying factors that drive consumers' trust in online sellers. What she's done is created a survey. There are 20 statements, and respondents rank each statement for how much that would increase their trust in an online seller. For example, number 1, the website allows purchases without requiring an account. We would call that a guest purchase. So on a scale, in this case, from 0 to 5, where 5 is the maximal increase in trust, how much would that make you trust this seller more? So we have 20 of these, and we can use exploratory factor analysis to try to uncover latent factors or facets or aspects of trust in an online shopping experience. So here are the data, and you can get these from the journal. I should mention, you'll receive a link to a recording of this webinar and to download this journal after the fact. But you can also access the data directly alongside the case study document. So here we have, across our 20 survey items, we have 445 respondents. And here's the factor analysis that we are about to perform here. So just to get right to the heart of it, you can see I've left up here our rotated factor loading table. So this is where we actually take the loadings, combine them with our domain knowledge to try to interpret what the underlying factors might be. And so I have highlighted here or darkened the high loadings. And we can see, for example, for factor 1, the items that load most strongly are being allowed to make a guest purchase, being allowed to opt out of website cross-tracking or cookies, being able to opt out. In this case, opt out means opting out of additional marketing emails. And then finally, personal info being a statement about how they're going to handle and protect your personal information. So all of this seems to be related to, let's call it, privacy in the online shopping experience. Whereas factor 2, we see high loadings for whether you've seen advertisements for that online seller elsewhere, whether they have testimonials from satisfied customers, or whether they have a celebrity endorsement. And so this might be more along the lines of, say, their public reputation or public visibility. So how do we perform this factor analysis, and what are some tips for using this with students? Well, we're going to start by going to Analyze Multivariate Methods, and we're going to go to Factor Analysis. And I've noted here in the journal that factor analysis, while a general name in JMP, specifically means for exploratory factor analysis. And we're going to do confirmatory factor analysis, or CFA, in the structural equation modeling platform in just a few moments here. So I'll grab all 20 of our variables, put them in the Y columns row, and click OK. Now you can notice there was no factor analysis already performed for us, and that's in part because we need to choose the number of factors and also the rotation method that we want to use. You can see the list of supported rotation methods here is pretty extensive. But to choose the number of factors, we can use the outputs of principal components analysis that's already been done for us. And if you're interested, by the way, in teaching principal components analysis with JMP, we actually just covered that 2 weeks ago. My colleague Volker covered that in a previous webinar, and that's available in the JMP Academic webinar library. So you can just Google JMP Academic webinar library to find that. So we have, of course, as you would expect, then eigenvalues and a scree plot here. You'll notice JMP has populated a value of 5 for the number of factors by default. I'm sure you will get students saying, why 5 factors in this example? Or, they'll notice that across different data sets, that default number changes, and they're going to ask why. So know that JMP defaults to a number of factors equal to the number of eigenvalues with a value greater than 1. So you'll notice right here, the eigenvalue for the 5th principal component is 1.02, but for the 6th is 0.86. But of course, if you want to teach students to, let's say, use the elbow method instead, you might look over at our scree plot here and say, oh, well, it looks like a 4-factor solution might be justifiable here as well. So when we're ready, we can set up the number of factors, the rotation method. Also, just notice you can do principal axis or maximum likelihood as the factoring method. And then finally, for prior communality, just note, and hopefully students won't do this, that if you click here for principal components where the diagonals of the covariance matrix, the correlation matrix equal 1, then you'll be doing PCA. So we'll want to make sure to stay down here. So I'll click go, and we get a number of outputs, more than what I had pulled up by default before. So we have our final communality estimates, the variance explained by each factor. If we do maximum likelihood, then we get these significance tests as well. So what do we see here? Well, we have a statistically significant result with a small p-value here, so we can reject the null hypothesis that there are no common factors. There must be at least one. And here's a test against the null hypothesis that 5 factors are significant. And with a p-value above 0.05, we don't reject that. So we can say it looks like 5-factor solution is an acceptable one. Look at our measures of fit. If we're satisfied, finally go down to our factor loading table and try to interpret these loadings. Now, note that you have control over the level of dimming that we saw before. So that is, actually, when we first saw this, I had a dimming value more like this, where the high loadings really stand out. In fact, I even increased the threshold a bit. So this is where it says suppress absolute loading value less than. So take the absolute value of the loading, and anything less than that absolute value here will be subject to this amount of dimming right here. And so in this particular case study, we have, a nice clean solution here, though it's probably important to show with students, well, we're making an arbitrary choice about what counts as a big factor loading. So we might want to show them that, the interpretation might really matter on how you actually set your dimming up. But for this example, I think I chose something like 0.2 for the dimming and 0.5 for the loading. But this is handy to really help focus students' attention, because you can imagine if you don't dim anything at all, again, we're asking students to look at and interpret a giant wall of numbers. And for most students, that's just not a reasonable request when they're first learning these methods. Now, to further explore these factor loadings, head on down to the factor loading plot. You're going to notice in these loading plots, where each one represents loadings across two factors, we have these variable labels, and I have my fonts for labels set a little bigger in JMP, and now it's all busy. It's hard to actually see anything. So go ahead and turn the labels off if you need to with this little tick box. So what can we see here? Well, for example, this topmost plot is showing the loadings for our 20 variables with factor 1 on the x-axis, factor 2 on the y. And one thing I notice is a group of variables right here that load very highly on factor 1, not at all on factor 2. I can hover over those to see what those are. So this is, again, this is that privacy factor. So we have guest purchase, cross-tracking. There are actually 4 here. These 2 are highly overlapping. Personal info, and then this last one should be opt-out. And so it's nice. I can select these 4 variables and then see their loadings across all the other factors. And so really what I would do is look straight down here to see, do any of these deviate on the y-axis at all, suggesting that we have the same variables loading highly on multiple factors. And we don't. They're basically hovering around the 0 point on factors 2 through 5. Or to put it another way, all of these right here are plots that don't involve factor 1 at all. And so we would expect, if we have good separation between our factors, that all of these points should actually just be living, at the origin of all these graphs. And it looks like they are here. So you have 2 different ways of exploring the factor loadings here. You have this interactive visual way. You also have this table up here where you can use dimming to help focus students' attention. Now, finally, you might want to work with the factor scores. So know that for any model you fit, you have a red triangle menu next to it where you can request additional information. In fact, you can see only some of the outputs are displayed by default. And all the way at the bottom, you can select Save Factor Scores. So I'm going to save these to the table, and now I can explore them further with JMP tools, or maybe even something as simple as right-clicking and just going to the underlying formula to demonstrate to students how these factor scores are actually being calculated. And if you're curious, you can find this in the documentation. They're using the Thurstone method here. Now, there's just to give you one idea of what you might be able to do with this. If you remember, when we first fit this model, we had a 5-factor model, and we used a Varimax rotation. So that's an orthogonal factor rotation. So we would expect that in our sample now of factor scores, we should see low or near 0 correlations among those factors because we chose an orthogonal rotation up front. So let's just go back to the multivariate platform, grab our factor scores, throw them into the Y columns role, and heck, I'll even go back to that platform preset, and I can see that almost all of these are in fact near 0. We have one slightly larger one at about 0.23 between factors 2 and 5 here. And so it's really easy to do something like compare and contrast different rotation methods. Under the model launch, I can fit multiple models. So let's actually choose an oblique rotation method. I'll click Go, save those factor scores. So here they are. So these first factor 1 through 5 right here, that was with the orthogonal rotation. This is with an oblique rotation. And let's put those into the multivariate platform here. We'll get back to our platform preset and now take a look at the differences. So here we actually see some correlations. In fact, one particularly high, 0.75 between factors 2 and 4 in the heat map there and the scatter plot matrix here. So right off the bat, we have a pretty simple way of demonstrating the consequences of the different choices we make about what rotation method we use. And it's pretty easy to help students develop a more intuitive visual understanding of what exactly that means. So that's factor analysis and some tips for using it in the classroom. Also, again, you can click here in the journal to go to the case study for exploratory factor analysis of trust in online sellers. And let's see. Yep, we're just approaching the halfway point. Paolo, how are we doing on the Q&A?
Yeah, we have a couple of questions, Ross. One is about the how to set dimmed loadings to 0 before saving factors.
Okay. Let's see. So we're saying that if we've dimmed some of these, we actually want to set them to 0 before we... I don't believe that that's possible.
Okay.
Yeah, the factor scores are ultimately going to depend on when you save them out, the formula actually being used is going to utilize all of the loadings regardless of dimming status.
Okay. One other question is about the, so if factor analysis is good for even very wide data sets, and of course, if it's a method that is also robust for missing values.
Oh, sure. Well, so by good for wide data sets, I think it depends on the data set here and the correlation structure among those variables. You can certainly use factor analysis on particularly wide data sets. But without being able to see the particular data set, I'm hesitant to comment in any greater detail. And then as far as estimation methods go, you'll notice that there are a number of different estimation methods here that you can use, some of which are more robust to missing values. The least robust would be pairwise, where this is actually looking at if there's any row that has a missing value in even one variable, then that's excluded. But others are better. So I recommend when you go to the factor analysis launch, click the help button right here. That'll take you to the documentation explaining the estimation methods listed here, and you can make a good choice about which one to use. All right, thanks, Paolo.
Thanks.
Do we have any more? Or it looks like we might have one more here.
Yeah, we have one more about how were variables ordered in terms of loadings.
Yes, let's see. Oh boy. So we're saying, I'm guessing probably right here in the factor loading table, how are they ordered in terms of loadings? And this is one where to be positive, I would want to check the documentation again. I believe it is that they are sorted with respect to the magnitude. No, because now I'm looking at the table and I was about to say sorted by the magnitude of the loading across. Oh, no, I'm misspeaking here. I was about to say sorted according to the magnitude of the factor 1 loading, but that's obviously not the case because that's not holding here. So I'm going to have to punt on that question because I don't remember. But this is a good time to point out that if you have questions like that, and you want to get into the JMP documentation to check on the answer, I recommend using the help tool. So you can access it in the toolbar or just under tools, and it looks like a little question mark. And you can go ahead and then click on a certain section of the report, and that will take you to the relevant page of the help documentation to try to answer your question. So here we're in the factor analysis section of the documentation here. So sorry, I don't remember off the top of my head how that ordering is determined. Okay, great. Looks like the Q&A is clean then. So let's move on to talk about structural equation modeling, and specifically for CFA and then also for structural regression. Or you might also know that as path analysis with latent variables. But I'm going to begin just by introducing you more generally to JMP's SEM platform, and then we'll actually use it to perform those two kinds of analyses. So the SEM platform lives in the multivariate menu. You're going to find it right here, structural equation models. But I do want to note that you will only see it there if you have either JMP Pro or the JMP Student Edition. If you're not familiar with the JMP Student Edition, this is a new software offering from JMP. It has all the statistical capabilities of JMP Pro, plus it comes with this student menu that includes a number of different teaching applets and calculators. And it's completely free for use in academic teaching and research. So if you're a student or a faculty member or an academic researcher at a degree granting institution, you can go to jump.com/student to access the JMP Student Edition, and then you can teach structural equation modeling. So I mentioned that we're only going to see CFA and structural regression here. Of course, SEM is a really wide modeling framework that can fit many different types of models. So I've included in the journal, and you can browse this at your leisure later, a link to the page describing the types of structural equation models that JMP can fit, from path analysis, confirmatory factor analysis, measurement error models, mediation analysis, structural regression, latent growth curves, and multigroup analysis. And you can read up more about these model types in JMP on this page here. And I've also included a link to an add-in on the JMP File Exchange, which lives at our user community, community.jump.com. It's called the Moderation and Mediation add-in, and it's for fitting a variety of conditional process models. So if you teach conditional process models, know that you can go here to download an add-in developed by JMP staff to fit those models as well. So with that said, let's bring up another case study and data set that we're going to use here. So at jump.com/cases, you're going to find right under our exploratory factor analysis case, this case, modeling online shopping perceptions. And the idea behind this case is similar to the previous case. We're talking about trust in online sellers, but now our marketing research analyst is studying how different aspects of shoppers' trust in an online seller influence their intent to make a purchase from that seller. So she's now using a previously constructed survey instrument and going to perform a confirmatory factor analysis, and then after that, test two competing theoretical models about relationships between various aspects of trust and the intent to make a purchase. So for example, model 1 here says that perception of privacy, perception of the seller's reputation, and perception of the security of the website all influence overall trust in this shopping experience, and then that influences your intent to make a purchase, but that also perceived security independently influences purchase aside from influence of trust. And the second model is proposing that in addition, we also have the seller reputation directly influencing that intent to make a purchase. So we're actually, when we do structural regression, I'm going to move on to a different example just to show you yet another data set you can use with your students. But know that this case study we're about to do for confirmatory factor analysis, you can also do for structural regression. So here's the data. So here we have data from 843 individuals where they have responded to a survey about a recent shopping experience, and were asked 4 questions related to their perception of privacy, 4 for their perceived reputation of the seller they were purchasing from, 5 on security, 4 on the general trust in that online shopping experience, and then finally 3 for purchase intent, or PI, as we're calling it here. And we're going to construct a confirmatory factor analysis, but first I just want to show you how the structural equation modeling in platform works in JMP Pro or the JMP Student Edition. So like I said, you'll find it under multivariate methods. I'm going to take, just for this quick demonstration of how this platform works, just 4 of our survey items, or what I'll call our indicator variables, put them into the model variables role, and click OK. So what we do is, in the SEM platform, is specify 1 or more model structures and fit them, and then each model comes with its own red triangle menu to request outputs and work with that model further. So step 1 is actually constructing our structural equation model. And you can do that using the interactive path diagram right in front of us here. So let's say that I wanted to just specify a regression between privacy 1 and privacy 2. I could right-click on privacy 1, choose Add Regression, click on privacy 2, and now I've added a regression between those two. If I want to remove that, I can click right inside the diagram and click Remove. And now we're back to where we started. Additionally, you can use a list-based interface right here. So for example, if I wanted a regression from privacy 1 to privacy 2, I would select them in their corresponding lists and click the single arrow button. And now we have that regression. Note that this double arrow button right here would introduce a covariance between these two. Now, last time I selected our regression and clicked remove to remove it, but you can also use the undo button to undo the last step in constructing your model, or click reset to just get back to where we started. Now, finally, we're going to actually work with these a little bit more. Down below, for some common model structures, we have model shortcuts. So for example, we are about to use the confirmatory factor analysis shortcut in just a moment. Last thing to note, you may want to add latent factors to your model. To do that, you select the relevant manifest variables in the to list, and then down below where it says latent 1, you type in the name of your latent variable. So I'll just call this privacy and click plus. And so now you have your latent privacy variable as a circle. Your manifest variables are indicators here as rectangles. And so you'll notice we have our loadings indicated by these single arrows. We actually also have the variances denoted by the double arrows. I mentioned before that you can specify covariances using our double arrow button as well. And one thing I want to point out to you is that a mean structure is actually fit automatically, even though it is not shown right here. But if you want to make that explicit, especially for students who are just learning this the first time, you can right-click, go to Show, and show mean/intercepts to show those model parameters as well. Now, finally, before we fit a model, you can actually look at lists of all of your model parameters. So we have our means and intercepts, the 4 right here that we just revealed. We have the 4 loadings that we specified, and we have the 5 variances. In this case, no covariances and no regressions. And then finally, in the status tab, we have a number of identification rules and whether or not the current model passes them. The big thing to note here is that this icon, if you have specified a model that cannot be identified, will turn to a red X. And then you can look here to see which identification rule has been violated, and then by that, figure out how to solve that problem. But once we have our model and we're ready to fit it, we would just click Run. Now we have our path diagram with all of the parameter estimates filled into the diagram and provided in a parameter estimates table, along with fit statistics and a red triangle with a whole lot more to it. And as I mentioned at the beginning, we're going to try to stay high level. I'm not going to even attempt to go through every single one of these today, but just know that each model comes with this red triangle menu where you can request a wide range of additional outputs. Now, finally, last thing I want to mention is that the path diagram is highly customizable. So whether it be up here in this path diagram or when you're specifying the model, you can use a few buttons. So here, actually, first, I'm going to hide the means and intercepts to, for example, quickly rotate the diagram in various ways, or under the gear, instantiate a large number of customizations as far as colors and line weights and what is being displayed. For example, Jump by default displays filled or shaded spaces inside each of these shapes to denote the R square. And if you want to turn that off, you can go ahead and turn that off. So a lot of us probably have a specific way we want our path diagrams to look, whether that's to align with our textbook or our slides, or maybe the conventions or standards of a particular journal. Note that you can do that, set them up here, and then use Save to Preferences to actually save these as your global JMP preferences. Now, you may also want to then share those preferences with students And I've included a link here. If I just click cancel right here for an add-in that you can use to easily export your global JMP preferences. So I mean these preferences right here, so everything in your general preferences, to then share with your students. So that's just a quick primer on the structural equation modeling platform. Let's actually use it now to perform a couple analyses. We're going to do a confirmatory factor analysis first. We're going to stick with our online shopping case. So to perform confirmatory factor analysis here, I'll pull up our structural equation models platform, put all of our indicator variables in the model variables role, and click OK. So as we saw before, we could manually specify a CFA model. I could create our individual latent variables. So I could go through this list and create each one. I can specify covariances if needed between the latent factors and so forth, and then run that model. That's going to take a little time. Certainly for students brand new to it, it might be either intimidating or error prone. So I recommend using the model shortcut that I briefly showed you just a few minutes ago. So let's go to Reset. And under Model Shortcuts, I'm going to go to Cross-Sectional Classics and Confirmatory Factor Analysis. Setting up our latent factors is essentially the same. So I'm going to just say, these are my privacy indicators. These are my reputation, and so forth down the line. And then as I'm doing this, I'll also point out that if you look to the right, you're going to notice something that says factor covariance. And our choices are orthogonal or oblique. And so that is where we can specify whether we want to include covariances between our factors. I'm going to call this last one purchase, click plus. One thing I neglected to mention before is once you've added latent factors to your model, they will appear in the same list as your manifest variables, and they'll just be blue and bolded here to let you know that those are latent factors. I'm going to stay with an oblique factor covariance setting. And now the model is specified for me. So I'm going to give this model a name. I'm just going to call this CFA and then click Run to run the model. So again, we have all of our parameter estimates filled into our path diagram. We have our fit statistics. Note, and I haven't mentioned this yet, up above we have, here I'll just kind of focus us a bit. We have this model comparison table where we have the CFA model that we just fit, but we also have the unrestricted, or that is a saturated model, and the independence model as our two baselines. We also automatically have performed a chi-square test against the unrestricted model, and you'll notice here that it's statistically significant. But we have a particularly high sample size, so again, 843. So it's likely that we're going to ping that test. We also have our CFI and RMSEA values up here, and those are both looking pretty good. CFI over 0.9, RMSEA less than 0.1. And so even though we have a significant result, this seems like a reasonable model to continue with. So if we're doing CFA, I want to point you immediately to the red triangle option, Assess Measurement Model. So this gives us a good CFA report, allowing us to assess the reliability with which we're measuring our factors and also the construct validity. So let's walk through these outputs just briefly so you know what we're looking at here. Under indicator reliability, we have the indicator reliability values. These are just the squared standardized loadings. And we have a graph of these loadings over here with a red line at a suggested cutoff of 0.25. So anything below that value, we would say that we might have a problem with that particular survey item that we'd want to address. That is, it might not be a great measure of that factor. It could be being influenced by perhaps other factors or noise. In this particular case study, reputation 3, security 3, and security 5 all look like they have problems, especially security 3. Now, before moving on, I did mention the indicator reliability. These are just squared standardized loadings. And if we look back up at our path diagram, you're going to notice these are unstandardized parameter estimates. They correspond to the unstandardized parameter estimates that we're looking at in this table here. Know that you can always pull up the standardized parameter estimates by right-clicking and under Show, going to Show Estimates and switching to Standardized here. You can also, I should mention, at the outset, if you know you want standardized parameter estimates, you're going to find a tick box right here in the launch dialog. Now, one nice thing you can do with this then, at least in the the context of CFA, is demonstrate the relationship between these loadings and the indicator reliability estimates. For example, let's just take 0.652 squared. That equals 0.425. So that should be the indicator reliability estimate for privacy 1. And if we go down, sure enough, the indicator reliability estimate for privacy 1 is 0.425. Slight difference there due to rounding in the way that the parameter estimates are displayed, but that might be a nice quick demonstration to try to demonstrate to students where these values right here are actually coming from. Now, if we move to the right, we have composite reliability and construct maximal reliability, or coefficients omega and h, you might know them as. Again, we have the values and graphs with suggested cutoffs at 0.7. You'll notice we have in this particular case study a potential problem with the security factor. No surprise there. I mean, security 3 is looking particularly bad. And then finally, down below in the construct validity matrix, the values are all explained right here, but just to get to the heart of it, on the diagonal, we have the average variance extracted, so the average indicator reliabilities. And then above the diagonal, we have the factor correlations. Excuse me, I should say squared factor correlations. And what we're looking for is whether for any given value, or I should say box on the diagonal, where larger and darker means a higher value, if there is a larger, I should say even larger or even darker box above it or to the right. If so, we may have problems with the validity of that construct. And right away, in this particular example, you'll notice security, pretty low average variance extracted. And actually right here, we see a larger squared correlation with trust. So in this particular case study, if you go to the document, the PDF there, what ends up happening here is based on the CFA, we exclude reputation 3, security 3, and security 5, rerun the CFA, the results look much better, and then it moves on to a structural regression. But like I mentioned before, I don't intend to do that structural regression right now. We're actually going to use a different example just because I want to show you even more examples you might be able to use in your teaching. But before we do, just note, if you're teaching CFA, you might want to teach multigroup measurement invariance. It's a necessary step in validating measurement instruments in a lot of different contexts. In this journal, I've included a version of the data set that you can use to do that. So it's the same data set, but now we've introduced a binary group variable where this is the reported frequency of shopping online for the individual respondent. So high versus low. JMP's SEM platform can fit or can perform multigroup measurement invariance or just multigroup SEM in general. And the only difference up front is that you take your grouping variable and you specify it in the groups role. Here for this one, I'm going to keep it simple. We're just going to take a look at our trust factor here. And actually, I'm going to standardize the latent variables up front. So you'll notice now that I've specified a grouping variable, I have this set equal button, which is what allows me to specify equality in a parameter across groups. So for example, if I were to just take a regression, trust 1 against trust 2, and I want that to be equal for both the low and high groups, I would select it and choose select equal, choose which groups I want it to be equal across. And now in the path diagram, it's going to be labeled. And that's how I know when I look at the individual group path diagram. So here's for the high group and the low group, when a parameter is being fixed to equal across them. Now, if I decide I don't want to do that, I can click that and click free to freely estimate it separately for the groups here. So you can use that basic setup to perform a lot of different multi-group analyses. I'm going to click reset though, and again, just go to a model shortcut to perform this analysis. So let's go to multi-group measurement invariance. It was grayed out before, but it's available now because I've specified a grouping variable. So I'm going to specify that trust is the latent factor that I'm interested in, and then you'll notice we can fit up to certain specified levels of invariance. So weak or metric invariance, strong or scalar invariance, or strict invariance, or I can just do all of them by clicking this box here. So when I click OK, you'll notice that we've fit and compared automatically all of these different levels of invariance. So for example, here is the chi-square test for weak invariance against configural invariance. We can see we don't have a statistically significant result, so we have evidence, or we can't reject that weak invariance doesn't hold. In fact, if we go all the way down, we can say the same for strict invariance here. And we have those models to work with. So here's our strict invariance model. Can show students, in fact, what that means. So again, when you have these labels like A1 or C3, that means that these were held equal across the groups. And so for strict invariance, what we're saying is it's a reasonable model to force across the groups the factor loadings, these intercepts, the intercepts down here, and the variances right here. And this allows us to make a wide range of inferences then about the differences in the factor values across the groups. So that's just a quick overview of both how multi-group analysis works, and in particular, multi-group measurement and variance. There's, of course, a lot more to it, but for the sake of time, seeing that we have about 9 minutes left, we'll take a quick look at structural regression before then wrapping up with a brief review of teaching resources, many of which I've already shown you, and then fielding what remaining questions we have. So I'm going to move on. Again, that online shopping example has a structural regression component to it, but I'm going to open up another sample data set bundled in JMP. You can, again, access this in the sample index. This is the job satisfaction data set, where we're looking at satisfaction as measured by 4 different survey items, and its relationship in particular with leadership, that's _L here, and leadership's effect on conflict in the workplace. So we're going to use structural regression to compare 2 different theoretical models here. So in what we'll call the full mediation model, we hypothesize that good leadership leads to a reduction in workplace conflict, leads to greater job satisfaction. In a partial mediation model, we have that same path, but we also introduce a direct path between good leadership and greater job satisfaction. And you could imagine that would be the case. Good leadership reduces conflict, and that probably improves satisfaction, but good leadership also might provide, let's say, more clear expectations, and you're more satisfied in your job when you know exactly what's expected of you. So let's use the SEM platform to fit and compare these 2 theoretical models quickly here. So by now, I think we know enough to be able to do this. Note that, of course, here, structural regressions are going to require manual specification because it depends on the theories that you are testing here. But I'm going to go ahead and introduce a leadership construct or latent factor, conflict, and finally satisfaction. Now, to introduce our regressions, I'm going to take leadership and conflict in the from and to list, create the regression, conflict and satisfaction, create the regression. Here is our full mediation model, as I'm calling it. So we'll put full mediation as the model name and click run. We have this test against the unrestricted model. It's not statistically significant, so this looks like a pretty good model. Also, we have a CFI all the way up at 1 and RMSEA at 0, or at least rounded so close to where that's where we're displaying them here. So this model looks pretty good, but the question is, what about that partial mediation model, and is that one perhaps better? So I'm going to take the model that we just fit and just add one more regression, in this case, leadership directly to satisfaction. So now we fit this model. Again, this might be a good time to use some of these options for reformatting so that we can see more clearly all the parameters in the model. Let's call this partial mediation. Gotta spell that correctly. Click run. Now we have our partial mediation model. Now, one thing I haven't shown you yet is performing chi-square tests, nested model comparisons for multiple models that we fit. By default, each model that we fit is compared against the unrestricted model. We can see both the full and partial mediation models fit well by that metric, but we can also select 2 nested models and then click compare selected models to perform the chi-square difference test on any pair of selected models with just a click. And so what we can see here is that the chi-square test is nearing statistical significance at about 0.06. So it's a borderline result. I would say here, if we have theoretical reason to prefer that partial mediation model, we might say that that actually is, in this case, evidence of a better fit, or at least if I have to choose between them, I'm going to choose this partial mediation model and then go down here to actually interpret the results. And of course, as I mentioned, there are many different outputs you can request to do that. In this case, I'm just going to pull up one as one example. Perhaps here I want to assess the total effect of leadership on satisfaction. And there are two paths here. So leadership directly on satisfaction and also mediated via conflict. And so I'll choose total effects here. And in my total effects table, I'll find entry for, let's see, leadership and satisfaction, which is right down here. And there is my estimate of the total effect of leadership on satisfaction. This is just one more example here to help you understand how the structural equation modeling platform works, how to use it effectively, and another data set that perhaps you'll be able to use in your course in this job satisfaction data set. Now, it's just a few minutes left. Let's talk teaching resources. You've seen many along the way. What we haven't mentioned so far are a couple quick tutorial videos and PDFs in our JMP Learning Library, and that's at jmp.com/learn. So I've included links right here to the entries for factor analysis and structural equation modeling. If you've never been to jmp.com/learn before, it's a large collection of pages like this, where you have for each one, here, let me click play, mute that. Quick tutorial videos. This one is 2 minutes and 58 seconds long. It's actually the job satisfaction example, just walking through how to perform the analysis, where to click, what outputs to expect, and so forth. And then under View Guide, you get a 1-page PDF with instructions to reproduce exactly what you've seen in the video. So the JMP Learning Library contains a wide range of different topics. If I go back to all topics here, you'll see them here that you can use to either learn JMP yourself or also provide your students, so that when they ask you, well, where do I click to perform, say, factor analysis, you can say, well, just go back to the learning library. The link is in the syllabus or on your LMS. I provided links here to the 2 case studies that we've already seen, and you can access the full case study library at jmp.com/cases. And then I have a number of suggested data sets from our sample data index as well. And so again, to access that, you just go to Help Sample Index. This has been redesigned as of JMP 18. So if you're not on 18 yet, yours won't look quite like this, but I recommend getting on 18 with the JMP Student Edition as soon as you can. Data is selected by default, and you have a big list of sample data sets. You can find any of these in here. So for example, the first one I've listed, academic achievement, you could use for latent growth curve analysis. And so I'll just type academ in here, and now I can find that data table with a nice preview, some analyses that I can run via the red triangle right here to decide if I want to actually use this in my course. But that's it for today's webinar. Oh, wow, with at least, a few seconds left, I was convinced I was going to go like 10 minutes over today. Wonderful. So everybody, thank you so much for your time and attention. I am going to hang out and field as many questions as we can. Otherwise, I hope to see you at the next webinar. That's in 2 weeks. We're going to talk about teaching consumer research methods. So things like conjoint analysis, max diff, and things of that nature.